So for all the problems that I do in class and on the homework, you might have an issue where you have objects moving north, east, south, and west. Whenever an object is moving north, we're going to let that be positive. If an object's moving east, that will also be positive. So if it's moving south or west, then it's going to be negative and negative then. So in this problem, you have a car with an initial velocity of 24.5 meters per second east then. So you're given the initial velocity and you're given that it's 24.5 meters per second east. We're going to let east be positive then. The car has an acceleration of 4.2 meters per second square west. So that means the direction that the acceleration is going in is negative. So the car is actually deaccelerating then. And so let's go ahead and put my variables. This is my acceleration. What is its displacement? So this looks like is your unknown. What is displacement at the moment that its velocity is 18.3 meters per second east then? So I'm given the final velocity in this case, and it's east, so it's going to be positive then. So let's go ahead and write my givens. The initial velocity is going to be a positive 24.5 meters per second. My acceleration is going to be a negative 4.2 meters per second square. And again, it's negative because it's going in the west direction. And the final velocity is going to be a positive 18.3 meters per second. And for my unknown here in this case is displacement then. So my unknown is displacement. Now we could go ahead and figure out which kinematic equation we're going to use. So first, we're going to see which one has initial velocity. This equation has initial velocity, this equation has initial velocity, this equation has initial velocity, and this equation has initial velocity. Next, we're going to see which one has acceleration then. So this equation does not have acceleration, so I'm going to eliminate that one. This equation has acceleration, this equation has acceleration, and this equation has acceleration then. Next, which one has final velocity then? So final velocity is here. Final velocity is not in this equation, so I'll go ahead and mark this one off. And final velocity is here then. And finally, I need displacement then. So this equation does not have displacement, so I'll go ahead and cross this one out. And displacement is here. So for this problem, I'm going to be using this kinematic equation to solve the problem then. So we're going to go ahead and write out the equation that we're going to use. So final velocity square is equal to initial velocity square plus 2 times acceleration times the displacement. Since my unknown is displacement, I'm going to have to rearrange the equation. So I'll start down here. Final velocity square is equal to initial velocity square plus 2 times acceleration times displacement. The first thing I would do is subtract the initial velocity from both sides. So I'm going to subtract initial velocity square. This will cross out. So on the left-hand side, I'll be left with final velocity square minus initial velocity square is equal to 2 times acceleration times displacement. From here, I'm going to get displacement by itself. So I'm going to divide both sides by 2 times the acceleration there. So this and this will cancel out. So on the left-hand side, I'll be left with final velocity square minus initial velocity square all over 2 times acceleration, and that will be equal to displacement then. So I'm going to rewrite my equation one more time. Final velocity square minus initial velocity square all over 2 times acceleration equals to displacement then. I'm going to go ahead and plug in my values. The final velocity is 18.3 meters per second, so I'm going to put that squared, minus initial velocity, which is 24.5 meters per second, and I'm going to square that. Divide that all over by 2 times the acceleration. Remember, the acceleration was negative, so we have negative 4.2. I'll go ahead and simplify the top. 18.3 squared, that turns out to be 334.89 minus 625 all over 2 times negative 4.2. That gives me negative 8.4. I'll go ahead and subtract the two numbers. That leaves me with negative 265.36. All over negative 8.4. Dividing negative 265.36 by negative 8.4, I should get a positive 31.590. Now, because I'm dealing with displacement, the unit for displacement is going to be meters, and this should be my answer then. Now, to double check if my answer is correct, I'm going to first rewrite my answer. So the displacement I found was a positive 31.590 meters. First, I will check the units. Because I'm dealing with displacement, the units should be in meters, so that checks out. Next thing I want to check is the sign. In this case, I have a positive sign. Because the car was traveling to the right, that means that he should be having a positive displacement then, because he's only slowing down and he's not changing complete direction, meaning he's not moving to the left at all. So having a positive displacement makes sense. And is the magnitude realistic then? So in our case, 31.590 meters, that would seem reasonable. You're checking to see if it's too small, like 0.1, 1, or 2. And to see if it's not too big, like 1,000, 2,000, or 3,000 meters or so. So for our case, our magnitude does seem reasonable, so this is our final answer then.